We are the Feedlot Feeding Control System Group, sponsored by Mayor Ranches. I'm Ethan Lange.
I'm Luda Mazan.
I'm Jordan Light.
The current problem Mayor Ranches is facing is inconsistent feed distribution. An example is shown on the picture to the right. Cattle have the tendency to come to the same spot on a bunk on any given day. With unevenly distributed feed, cattle will either overeat or undereat, causing inefficient weight gain, which in turn reduces profits for the feed yard. One strategy to increase profits by potentially $50 per head is called limit feeding. Limit feeding feeds the cattle roughly 92% of the max intake value. In order to make sure the correct amount is fed, the SDSU feed bunk scoring system is used. The score of 0.5, or scattered feed remaining, is an optimal score for this system in a picture shown on the left. Our system will evenly spread the corrected amount of feed along the bunk length, which can increase weight gain and therefore increasing profits of the feed yard.
So what the sponsor initially requested was to control the feed mass flow rate and to lay out the perfect feed distribution. He wanted us to use GPS for the speed, which we decided wasn't going to be accurate enough, and he wanted us to use Bluetooth to pull in the scale weight. They use performance beef currently to keep track of their target versus their actual weights, and he thought it'd be ideal for our software to integrate with performance beef. The system will be semi-automated because they will still use some user input. The system will be duplicated for 2 different feed wagons, and the budget he gave us was $2,000. The acceptance threshold we were given was 10 to 15%, and our personal goal is to go below that.
Mayor Ranches currently uses performance beef to track the amount of feed fed per pen, along with rations and other useful data. During the loading process, performance beef is also used to achieve the correct weight for each ingredient when loading. When unloading, the driver starts the feed wagon PTO and opens the exit door to let the feed out. The driver then varies the ground speed to try and to evenly distribute the feed along the given bunk length, as seen in the video. This is where their system falls short.
When studying the data, we concluded that so far this year, the feedlot has distributed over 40,000 pounds of feed, which equates to about $7,000 at current market value. A majority of this, at 30%, was distributed to Pen 9. Pen 9's ration was individually mixed and delivered. The second highest was at Pen 2. The percentage deviation off target per ration is in this chart. The highest deviation at 7.5% is the ration listed here, with a dry percentage of 67.7%. We saw no trends related to the ration type, pen number, or weather related.
Some of the competition that we found was the Lely Vector, which is a fully automated feeding system that automatically loads and feeds. Some of the drawbacks to it are the cost. It costs around $250,000. It only can feed a limited number of cattle, so it's more oriented towards dairy applications, and it's only able to operate on smooth surfaces.
For our decision matrix, we rated it 1 to 5, with 5 being the best. In the cost category, we considered the buy-in cost or the purchase cost, as well as training or skilled labor. For maintenance, it is the repair cost per operating hours. We expected the more automated system to require service contracts or specialized technicians. In performance, we took into consideration the accuracy of feed distribution regardless of feed type. For ease of use, we considered the amount of specialized training and the complexity of the system. For flexibility, it includes the ability to move the system from tractor to tractor.
Our proposed solution is to use a Raspberry Pi along with an electric hydraulic directional control valve in order to actuate the feed door. Some of the inputs to the system will be speed, weight being dropped off by the feed wagon, the ration type, and the length of bunk. This will all run through a program within the Raspberry Pi. Then this will feed an output into the directional control valve, which then activates the door into either open or close depending on the output.
So our proposed budget plan is to use a hydraulic directional control valve, Raspberry Pi, additional expenses including sensors and wires, and that comes to a total of $500. And considering both systems, it will be $1,000, which is half of our given budget.
To consider success in our system, it would have to deliver feed consistently for an entire bunk, for all operators, and for all ration types. To evaluate our system, we will be collecting 1-foot sections of bunk as shown in the picture. Again, this would need to be at a 10 to 15% accuracy rate from target.
So some ways to improve our system in the future would be to use app control, so to design an app so they can use that on their current iPad. To use GPS so you can determine your location and it can pull information about the bunk that you're at. To automate inputs to limit operator error. Possibly integrate with performance beef, and to make all components IP67 rated, which is industrial grade.